Hello everyone, welcome to the tutorial series of Python language quantitative trading practice. We have learned about the concepts of model execution and time series in Python language. Next, we'll move to the script structure in Python language. If we want to query some Python language functions and built-in variables, we can query in the FMZ API documentation page. Here we can click on the API and click Python language script. Python language script documentation in the page. And we'll jump to the Python language documentation page here. In this document, we can find some functions and built-in variables we need to use. Of course, you can also use Ctrl+F for global search here. We use the test strategy in the test strategy library to explain the general structure of the script. The general structure of Python language starts with the variant declaration of variant. Followed by a declaration statement. The next part is the code. But this code is a description of the structure and not the real code in the variant declaration. The Python language starts with variant at variant equals to 5. Of course, this can be omitted on FMZ. We name it with strategy or indicator function, and of course, the indicator function can be omitted. So we name the function as strategy directly. And the rest is part of the strategy code, such as strategy logic, variables, some statements, etc. In the strategy function, only the title, short title, overlay, parameter, default quantity type, default quantity value parameters are supported. The last three parameters are more important. They are mainly used to control the behavior of the trading script. Let's take the first parameter, default quantity type, as an example. When I specify default quantity type as strategy cash, at this point is an order by amount. Then we specify default quantity value as 500, that is, place an order in the amount of 500. Then we execute the order placement function, specify the color, specify the order name as short, and the trading direction as strategy short. If the denominated currency for the trading pair is USDT, then the order is placed for this amount of 500. Here we click on backtest. And we can see in the logs area, an order was placed. In the log message, of course, we can calculate the amount of orders placed plus the number of orders placed. In fact, it's an amount of 500. Such a parameter is used to set the trading options. There is another parameter. If we want all the drawing content to be displayed on the main chart, we use overlay and assign it a value of true, so that all the drawing content will be displayed on the main chart. In addition, it is possible to set specific settings on each function or specify parameters in the strategy function if you do not want to set specific settings on each function. Another important parameter is pyramiding, which is used to control the number of times a strategy can place a trade in one direction. For example, here we specify pyramiding equal to 3, meaning that if the strategy starts with the short direction, it is allowed to trade for 3 times in the current short direction. We can see that the strategy we just run only trade once. Because the default pyramiding parameter is 1. It only trades once, and it stopped trading in later periods. When the strategy continued to run, if pyramiding is set to 3, let's go back to the edit strategy page. If pyramiding is set to 3, because we didn't set the pyramiding parameter just now, it was default equal to 1, and here we set it to 3. And we don't change the next line of code. Here we click backtest to see it again. Then we can see in the log area, it was traded for 3 times. The amount is 500 to place an order for each time. So this pyramiding parameter is used to set the number of tradings in one direction. Of course, this function only affects strategy entry. If we use strategy order function to place an order, it shall not be affected. The order will be placed for the times was set. It is completely unaffected by pyramiding parameters. Default quantity type function can be found in the API documentation here of FMZ platform. We can click it and jump to the API basic instructions. On the basic instruction page, we can jump to the Pine script documentation page here, and we can find the default quantity type parameter in this documentation. As for the default quantity type parameter, we can choose cash, which means placing an order according to the amount. Fixed means placing an order according to the number of lots. Percent of equity means placing an order according to the percentage of the order. All of these can be set specifically. If you do not know the specific options, you can check in this document. Of course, you can use the Ctrl plus F in this page for a global search. If you want to write comments in the strategy code, since the difference between writing comments in TradingView and Pan language we have talked before, which only supports single line comments on TradingView, but we can use extended multi-line comments on FMZ, such as 1, 2, 3, ABC. This is the difference. In addition to the above comments, volume control, and other related information, what remains in the strategy code is the code, which we generally call statements. Statements are generally divided into variable declarations, reassignment of variables, function declarations, calls to built-in functions, calls to user-defined functions, and if statements, for, while, switch statements, etc. These in our previous demonstration has been displayed. Code examples have also been displayed. We will follow the detailed study one by one later. Here we can have a macro understanding. We usually use some rules when naming statements. First of all, the global scope of the statement cannot start with a space on TradingView, and it cannot start with a tab. But on FMZ, writing code starting with a space will not report an error, but not quite in line with the specification. Starting with a tab will report an error definitely. For example, if I declare a variable A and initialize it with an assignment of 55, it will run without an error. We can try it. We can see without an error there. But if I put a table in front of it and backtest it here, and we can see it reported an error. Which means that the Pan language code cannot be parsed. So we have to be careful that the strategy cannot start with tab. Declare a local function bar is up. At this time, we click on Enter. It will indent 4 spaces automatically, and we can write the function. For example, I write close more than open. This function will return close more than open eventually, that is, return a positive line, and bar is up is true. We call the function close more than open as a local code block. Of course, we can also use a multi-line assignment when using the if statement. For example, I declare a variable b. And then we use the return value of the function bar is up to determine it. If the return value is true, specify the color of variable b as green. If the return value is false, specify the color of variable b as red. Next, we use the plot function to draw a line. Let it draw all the closing price of the line, name it as close, and specify the color as variable b. At this time, it will draw a chart according to the value of the variable b, and then we click Backtest here. We can see that there are red and green intervals in the chart. That is, the specific drawing operation is done according to the judgment of the function at this time. This part of code, color green, is also called the local branch of the if code block, and so is color red. If bar is up is true, it returns to green. If it's false, it will return to red. This is the concept of the local code block. Of course, most functions need to be called in the global scope, and if the function is not executed on every bar, the computation results will be different. We often use the function runtime log called in the global scope, that is, to print variable values, variable information. For example, here we print the value of b. Then we click Backtest. So we can see there are data in the log area. That is, since the variable value is a color, it is recognized as the color of the log directly here. We can see green, red, green, red. If we set it as the last parameter, it defaults to the color of the log, so we see that the printed log has red and green. In addition to the fact that it can be written line by line in the strategy code, we can also use commas to concrete multiple single-line statements in one line. Let's take a runtime log as an example. Print 1, 2, 3, then enter a comma. We can write another runtime log and printing the string ABC. We can still write the third line of runtime log, print XYZ. Then we click backtest. We can see that the statements are printed in a continuous loop. XYZ ABC 1, 2, 3, XYZ ABC 1, 2, 3. Each time all statements are executed, 1, 2, 3, ABC, XYZ in a continuous loop. In other words, we can write single-line statements with commas to space them in one line. Usually, comments can be written in a single line, or we can write a comment or in a separate line within a statement. For example, if I write if we write if close more than open, we can write a comment in this place. Or we can write a comment at the end of the specific statement to be executed. It should be noted that the indentation requirements in the Pine language are very strict. For example, the spaces in front of the block must be indented strictly by 4, and if the spaces are not indented by a multiple of 4, it will be judged as a concatenation of the previous line of code. For example, if I declare a variable a and assign the value a and assign it a here, a equals to open plus high plus low and plus close. Actually, it's an expression that adds up the opening, high, low, and closing price of the current bar and assigns the value to A. If we split it into multiple lines, we need to be careful that the number of spaces indented in front of each line must be 4, or an integral multiple of 4, in order to be considered as a separate line. Otherwise, it will be considered as a concatenated line. At this point, we can click Backtest. And we can see that the test result has no problem here. We can draw it with the plot function. We can divide A by 4. Calculate the average price, name it as A, and draw it on the main chart. And here we click Backtest. And we can see that our average price is calculated. That is the average price of high price, opening price, low price, and closing price. We can also split it into 4 lines to write. Here we need to pay attention. In the front of the next line of code cannot be 4 spaces. If it's 4 spaces, it will be viewed as the same block of the previous line of code. Here we click Backtest. And we can see it reports an error. If it's not a multiple of 4, such as 5 empty spaces, we can try it. Then it is considered to be a concatenated line of code from the previous line. The same goes for the next line. We follow the 5 spaces in series O. And here we click Backtest again. And we can see the strategy is working properly. We need to be careful when indenting. If the if statement is a block of 1 code, it must be preceded by 4 or a multiple of 4 spaces. If it's not a block of code, the statement is a cascading line statement, that is, a single line statement split into multiple lines. The spaces in front of the code cannot be a multiple of 4. If so, it will report an error. Similarly, a long function call can be split into multiple lines. Here we write a call to a plot drawing function that uses a function TA correlation to calculate a piece of data. If we don't understand the function, we can consult the API documentation here. As usual, at this point, we start a new line, remembering that the spaces cannot be a multiple of 4. Set the parameter color, assign the value to new, set the color as purple. And then continue to write a new line, set the style to display the area. Oh, don't forget to add a comma here. And set the last parameter, track price equals to true. At this time, we can see that this is a one-line call. We can see the comma here. This is one-line call to the drawing function divided into 4 lines, and we click backtest here. And we can see it output. The content of the chart is the purple one. Then we draw according to the set type in addition to the above method. We can also write single-line statements as multiple lines in the custom function declaration. Of course, it should be noted that since the block must be intended by 4 spaces, or a tab in grammar, when we split it to the next time, the continuation of the statement must start with the above indentation. That is, the overall number cannot be equal to a multiple of 4 spaces, but it can be 5 or 6 spaces, keeping it more than 4 spaces at least. Let's use an example to demonstrate here. First, declare a function test with A and C parameter, with a C parameter and O parameter here. Written as a function body. The function among the return value. That is, the closing price is greater than the opening price. We move on to the next line of statements. where we write another ternary expression that takes the value of 1 when closing price more than the opening price plus 5,000. Otherwise, it takes the value of 0. Then we execute another expression takes the value minus 1 when the closing price less than the opening price minus 5,000. Otherwise, it takes the value of 0. At this point, the function has been finished. Here we create a variable a, assign it a value with test. Pass in the two built-in variables, close and open. We use the plot function to print out the drawing function for a, name it as a. And here we click backtest. Oh, it reports an error. We see line 16. We can see at line 16, we add it here. And then click backtest again. You can see that. This value is always 0 here. This value is always 0. Go back to the strategy code page. Because the function of the strategy function is actually to determine whether the closing price is greater than the opening price. If the closing price is greater than the opening price and more than 5,000, it returns to 1. Otherwise, it returns to 0. If the closing price is less than the opening price, then determine whether the closing price is less than 5,000. If so, it returns to -1, otherwise it returns to 0. Actually, it's used to determine the difference between the closing price and the opening price on a K-line bar. That is, whether the K-line bar range is more than 5,000. If so, it returns to 1. If the decline exceeds 5,000, it returns to -1. All other conditions returns to 0. Since we are using the 1-minute K-line, but the 1-minute K-line won't have such a great increase or decrease like this. So all the values here are 0. Let's widen the time span, widen the time range as 1 day. We know that the daily line of Bitcoin is likely to have such a great increase or decrease. Don't forget to set it as bar model here. So let's click backtest again. And we can see that in this chart, there are indeed several times that the range of increase or decrease more than 5,000. For example, this K-line, it increased from 0 to 1. Obviously, that is the price change of the opening price to the closing price is more than 5,000. And the decline of this one, we can see, it becomes -1 immediately. That is, its decline also exceeded 5,000. So we can observe that all the K-line changes, there are several times when the increase or decrease is more than 5,000. And we change these calls into a single line here. And we still need to note that the number of spaces here in front of the line cannot be a multiple of 4. In fact, it is a whole ternary expression among the set of ternary expressions. We can understand as return value, we can understand as return equals to closing price more than the opening price. The above is the indentation requirement for a single line in a single custom function with multiple lines. So that's all the content of today's lesson. And don't forget to like, follow, and repost our videos. See you next time.